This is the second video about the Jimmy Diresta toolbox, but there's a couple of things that I need to clarify. First of all, I promised last week that this would be about cam, and it will, but I'm actually more excited, I think, about the first portion of this video because I get to show some tips and tricks that I think is really useful. Second of all, there was a couple of people who pointed out that this is not a Jimmy Diresta design. It's an old design of a toolbox, and I totally agree with that, and I'm pretty sure that Jimmy would not claim either that he invented the design at all. It was just a quick little project he did on Instagram. As I stated in the first video, there is many different ways that you can attack a project like this. And this is just kind of how I would go about doing this on a Sunday afternoon. I'm especially excited about this video because we're going to cover a lot of small different things that hopefully helps people through the process. We're going to talk about timeline, we're going to talk about cam toolpath, we're going to talk about feeds and speeds, and I'll show you how I kind of approached doing this on my Stepcraft router. So with that, let's go. So here we are. Here is the model we finished up last week. Well, with the addition of this Diresta logo, you will see on the box here. I put that on afterwards for the thumbnail for the video last week. And that reminds me, so I made this, I just literally just went, on Google and I found Diresta's logo and then I photoshopped it. And it reminds me, in my last video, I showed this huge gap that I had down here when I put this together, and somebody complimented me on me willing to highlight my mistakes, and that reminded me when I looked at this model here, because I might as well just if you think that I have it all figured out, then you're kidding yourself. I had a guy emailing me I think it's probably like a month ago, and again my contact information is down in the description of this video. And he was trying to wrap a decal, and that's what this is, a decal. You find the decal up here on a kind of like a cylindrical thing. And he got kind of like this mismatch on it. And he emailed me and asked me how you could get rid of that. And I was like, you know what, I think maybe you're just stretching what you can do with a decal. But and it's kind of the same thing you're seeing here in the back here. And then he emailed me back and says, well, he had actually found the answer to his solution. If you go in and if we edit this, so right click edit feature, down here, there's an option to chain faces, and unchecking that, then it went away. And he actually left a comment saying that he was a little disappointed that I didn't know the answer. Trust me, I don't know all the answers, so I don't want to claim I do. All right, so let me just forget about this decal for a second. Let's talk a little bit about timeline. And I think this is, even if you're not into cam, then maybe later in this video when we get to that, you could always just shut off the video, go and do something else. But one of the things that is interesting to highlight with this project, I think, is a little bit about the things going on down in this timeline. And I'm assuming that you watched last week's video at this point, but if you didn't, that's fine too, of course. But you will see a couple of things. One of the things I want to highlight is, so you have this timeline down here, and we have all these different things recorded. And one of the questions I got, and by the way, remember that anything in this timeline is kind of like working in the order down here, like how we are reading things in the Western world. So, whenever Fusion is doing things, it's kind of starting at step 1, what in this case is a sketch that is hidden. Right, and then it goes to step 2, what is another sketch that is hidden, and step 4, like it's solving things in that order. And one of the questions I got in an email from last week was, instead of doing all these different joints we did to put this together, couldn't we? And I'm just going to move back to here. Couldn't we just have? So we grounded the bottom. Couldn't we just have done ground on every single component and achieved the same result as we would have done if we have done all that, we did all that in last week's video, we used this as-built joint. And the answer is yes. We could actually just have used the ground command on every single one on this model, because the way that Fusion is solving this, everything is solved in a direction starting from here, moving through. So even though that we have just, with adding all these grounds, we have kind of nailed all these pieces into space. If I go in and I change this sketch, so let's make this one 700, that means that things are still going to solve, because then after we change the sketch, then the next thing's going to go into place, and the next thing, and the next thing, and the next thing, the mirror and everything working, and then things going to be locked down. So there's kind of this history going on here, and that's important to know. And I'm gonna show you a couple of cool tricks, I think, in this exercise we're gonna do today. So let's make that back to 500, and we'll see things updates. And let me just also, I'm gonna hold down Shift and click on the first and the last, and I'm just gonna delete all these, and then go back to where we were. So that was one thing I just wanted quickly to answer. You could have used the grounding on all the ones, and you for this one. The problem with that, doing that though, is that it could give us issues in other scenarios if we were doing other types of models where this didn't kind of come in the end. Because there's almost like a natural workflow through here, right? Like we started with the free sketches, again, hidden on the eyeball. And then we kind of went through this process of creating a component, and then we created an extrude, another component extrude. We did a mirror. Somebody was asking me about, couldn't we have rotated this instead? Absolutely. We could have done that. We used a circular pattern for that instead of a mirror. Could have done that. So there's a kind of a natural progression until we get to this point here of all the parts. And that was when we got to the point where we're like, well, things could move around here, right? And then we started to lock things down. We locked down the base plate, and then we added these different joints, built as joints. Now, what we gotta do today with this is that now we are going to actually make this lay down flat, and then we are going to CNC it out. Now, the laying down this flat, we have some different options to do that too. And now, if you have the paid version of Fusion, there is some different options in here. There is a arrange function where you could lay everything flat, and there's also a nesting option. But to be completely honest with you, I haven't done all my homework on those functions yet to make a video on it, so that's on me. And I kind of started this project in the personal project or hobbyist license, and I'd like to finish there for this project. So we're going to do this the old-fashioned way. But as we're doing that the old-fashioned way, I want to show you a couple of ways, some really neat tricks that I hope when you see this really makes you think, oh, now maybe it clarifies some things on how you can work with things. With that, because I'm going to lay it flat, I could go into my manufacturing workspace, and in here I could decide to create a manufacturing model of this. And that would separate this view in the design, and I could do all the same things that I'm going to go ahead and do, but I'm going to choose here to do it still in the design workspace, because it gives me a couple of options to show you a few things. And then if we go into the manufacturing workspace and we do a create manufacturer model, if I just do that for a second, if I say I'll do that, what will happen when we go in and edit that is that we don't have anything in the timeline. But it's a good thing in general, but it doesn't, I think for anybody who's fairly new, that having this timeline in here would show you some different things. So, enough, let's get in and model things. I get long-winded, I know, you can tell me that. So what I'm going to do here is I'm actually going to kind of cheat a little bit in the sense that I am going to move back to where we were before. So I dragged back this timeline with all my different joints in here, what means that I'm back to the point where this can move around. Now I stop right here, so the ground one is still tagged in. And when you move things around in here, that's where we get these chains capture position that probably have left some confusion. You maybe haven't noticed these coming up, but you definitely have noticed that when you decided to go in and do another command, maybe not sketch. Oh yeah. When you went ahead and started the sketch, you got this command here. I'm sure you all have seen this, and it's kind of coming up in your way, and you're a little bit like, ugh, what is this? And I know I've explained this in other videos, but if you read the thing, it says that some components have been moved, and we realize that we've done that, and we now get a choice. We can choose to say capture the current position or continue in the previous position. And really what Fusion is saying here is, like, do I want to, and the same icons you have up here, do I want to continue, or do I actually want to nail this down in space? Now, if I say continue, then everything on the screen will go right back to where it were. If I decided to say I want to capture the position, then it would actually capture the position in the timeline as an event. What I'm going to do here is I'm going to say continue, but it's going to bring everything back to where it was, and it's going to start a sketch. So let's talk a little bit about, I'm going to delete this sketch here because I didn't really need that. So let's talk a little bit about that function that it captures versus not captures. So if I go ahead here again and I move a command and I initial the sketch again, and at this time say I want to capture the position, then you will see that I get this capture position icon down here. But it's not a bad thing at all. But now we can just work with this. And this stuff can actually be in your advantage. Let me show you by deleting these. We're going back to normal again. So let's lay this thing flat. And then we can talk some more about it. Actually, what I'm going to do is I'm going to hide the handle because I actually don't need the handle. Right? That rod, I just bought that at Home Depot. Now, the tool I want to use is another tool that have caused maybe some confusion for some between the joint we used last week, and we're going to use again, and the align tool. The align tool is a super good way to just kind of aligning two faces, edges, or points. And I'm actually going to use that here as my shortcut. Now remember that the base is nailed in place, so that's not moving. But all the four other components, I want them flat on that face. And again, there's add-ons that can do some of this. There is Arrange and other tools in the paid version. And there's different ways you could do this, but I think this, hopefully by showing this, helps people in other situations seeing what's happening. So let me go in and align this. And when I align things, I can go here and I can click on either a point. Let me spin around a little bit. You can either, you can see how you can snap to things, but you can also just select the face. That's what I'm going to do. I'm going to select this face. So that is, and you can select different things. I select the components here in the drop down. To this face. And you will see that it just aligned that body down to be flat to it. That's what it does from to, right? That was pretty obvious. There's a flip button. What we'll do, what you would imagine, we'll flip. Then there is a capture position. If I check this and hit OK, then we will actually get that capture position icon. You see that? Now, if I don't capture position, so let me right click and hit Edit. Well, actually, I don't think I can do that because that capture position is actually not the align feature. That is just capture the position. Let me delete it again. Right click, hit delete. What the? That's something I think maybe it just needs to solve something. Oh. Did I? Oh, sorry. It's sitting up here right now. Finish position. All right, there we go. Delete that. All right. It's always good when I'm struggling too. So let's go back into that align again. Align, and let's do the same thing. So I select somewhere on the face, and then I select to the bottom of this face, and it aligns it. If I don't check the box and hit OK, then nothing is down in the timeline. Now, but you will see, though, that Fusion have detected that something moved, because we can see that up here. It's knowing that I moved things. It just haven't captured it. Now, if I went ahead and did my sketch again, then we got that option up here where we could either choose to continue or capture the position. So I could actually have gone, so let me just, I know you guys are going to get sick and tired of me doing the same thing over and over again, but I could actually go ahead here and do a line and say, I want to do from here to here, hit OK to that. Nothing has been recorded in my timeline, nothing here. We could go ahead here and spin around, do a right click, recapture a line, repeat the line. That's a quick way to get back to the same command you just used. Then we do the same thing on this one. Hit OK. No, not capturing. Hit OK. See, like nothing is happening right now. I'm kind of like just working in this environment where nothing is getting recorded yet, right? Because you have noticed that at some point when I activate a command, I know the Fusion at some point is going to yell at me and say, hey, dude, you need to capture a position. And of course, we also know, all of us, that right now, this is not a way to produce this. I just kind of like got them all flat to the bottom plate. But I mean, of course, you can't machine. We need to move things around. This could be where we either just went ahead and grabbed one of these components and, and dragged it out. But if you drag it out, you see you're kind of dragging it out in three-dimensional place. That's really not going to work. So I'm going to do a Control-Z on undo. One tool that I would use here would probably be the Move Copy tool. If I select that, now I could select that component, and I could actually grab one of the arrows, and I could move that out. And I've done videos on this tool. And right now I'm actually going to use this Move Copy tool just to get them all out of the body. Now you will notice when I hit OK here, this automatically gets corrected in the timeline. But this capture position of us aligning things has not been captured yet, but it's kind of just interesting as a workflow. So I'm going to go ahead here and select and just move these out here. Hit OK, that gets captured. Right click, repeat. Select this one. I'm going to move that one out. Right click, repeat. I could probably actually selected both of those components and move them out at the same time. Let's do a Control undo, undo. Let's do that again. Let's right click and do repeat. Select that and that. We can select two components at the same time, and we could have dragged those out there. And those all three moves we just did got recorded, but the align function has not been recorded yet. So just remember that. But now I get to this position where I got them all laid out, but I actually want to be able to control the width, the gap between these parts, because I need to have an end mill running through here. So now I'm starting thinking about, I need some kind of a command that can actually give me exactly what that is. And then I would actually go back to my joint tool. That would be my preference. So what I'm going to do now, I'm going to hit joint, and when I do that, then the align tool says, okay, that's enough. Now you need to make a decision about what you really want. And if we don't capture the position, then things will actually go backwards. But in this case, I'm going to say, yes, you know what? Go ahead and just capture this position to this point. And then it will let me go in and activate the joint tool. Capture position. There you go. There it is. It will let me do that. Now, if I hit cancel, then it actually jumps back. So it wants me to do that joint. It understands that next comes joint. Okay, so what I'm going to do is I'm going to use the joint to line up the spacing and orientation of these. So I'm going to go ahead here and use the joint command to snap to this corner, and then I'm going to snap to this corner here, and the joint works like glue, right? So it just glued those two together, and that gives me an option to grab one of these arrows and actually put a specific width between here. And I'm going to use a 6mm cutter or a 1/4" end mill. So I'm going to leave 13 millimeters between these two for this. So about half of the or 2 cutters. So I'm going to do that. I'm going to hit OK. So now I have just placed. So I used that line tool to get everything flat, but now I'm actually just using the joint command here to line this point up with this point, right? With a certain distance. That's how I would do this. And I'm going to show you why in just a second, why it's pretty neat. And then we're going to talk about this timeline in a sec, come back to that. So I'm going to repeat joint. I'm going to select the same thing, that coin right there and that coin right there. Do the same thing. Grab the arrow and activate that direction. And then I'm going to make it 13 because that's what I decided. Now, so that position, these 3 pieces. This one here is kind of interesting between the 2 pieces because I need the 13 millimeters between the 2 pieces and then also between here. So let's do between the 2 pieces first. I'm going to hit a joint here, and I can place a joint between these two. So one of the things you can do is if you hold down, as the coin appears, and I've talked about this before, if you hold down Control on your keyboard, you kind of can lock it into that face. So now the coin can only work on this face because right now I'm holding down Control on my keyboard. If I let go of Control, then the thing will fly all over. That also works when I'm here on this edge. If I hold down Control, now it will only snap to this. So this is a good way for me to know what part I'm working on. If I don't hold down Control, it could be kind of hard. Jumping is trying to do right there. I really don't know where I am on what component. But if I hover over here, hold down Control, then I can make sure that I'm on that one there. And then it's pretty easy to go over and do the other one. And snap that in there. And then I can move them apart. 13 there. And now I got those 2. Now, then what I want to do is I actually now want to make a distance of 13 millimeters from the center between these 2 on this edge to this place here. But these coins, when you do a joint, you know, they travel within a component. They don't really travel between. See, you don't see anything between. But this is where, if I just cancel out of this, we can use the joint origin in here. So joint origin will let you create one of these coins, joint coins, wherever you want. So I'm going to select that, and then I can place one right there, but then I can actually move it out here. So that's going to be minus 13 divided by 2. I'm typing that right into the dialog box. Hit that enter. And now I have that joint origin or coin, or whatever you want to call it, right there. So now I can say I want to do from that to that right there. Only one part's going to snap in. That's fine. The other one will come along after I have done my 13 millimeters there. Okay? So now I have laid these parts out the way I want to lay them out. And again, it's kind of like the long way to do this. But if you don't have the paid version with arrays and other things and nesting, then this is one way to do it. Now I want to come back to this timeline though, and talk a little bit about this and how you could potentially work with this. And I know that I will show, like, doing this in the manufacturer workspace with the new option in there might have made more sense, but I wanted to show you kind of like this in the whole picture, because actually right now somebody could argue that these 4 bits right here are really not useful anymore, because we have now established every location with these 4 joints instead. So one thing you could do was you could go in here, and again I'm going to hold down shift and select these here, these 4. What you could do was you could right click on these and you could create a group for these, and I'm going to talk about groups in a little second, and then they would all be grouped together, and you can actually rename these groups. And I could call this move commands, right? Move, and then I know that I use these features as to align something, or you call them align, or maybe you call them miscellaneous, because they really don't do anything, but they do something or something. And then 6 months from now, when you're looking at this, it's not taking up your timeline, but it's sitting there, and you haven't, if you hit the little plus sign, of course, you can expand them out, but now they're kind of like sitting in there by themselves. You could also just take this and you could delete it. Delete the group and expand the content, delete both group and its content. We could delete them all because these 4 are aligning with those. The only problem about when I did this was that that now you wouldn't, of course, be able to ever come back and be like, how the heck did I do that again, right? We're kind of lost, a timestamp in our whole scenario here, doing it this way. But it could be a nice way to clean up the timeline if you got to share it with other people. Now, these groups could be super helpful. We could also go in here and make a group here. If we selected all these 4 joints and our joint coin, we could right click and create a group for those, and then we could rename that group. We could not also do it, but we could call this flats. And if we now right click on that group, you will see we can suppress all those features. If we suppress all those features, those joints, look at that. And now if we move here to the end, then you will see that now we have our old joints that we had originally put in last week back here. So those could also be grouped together if you wanted to. You don't have to do any of this stuff. And if we right click on that, we could call this assemble. Right? And you can always expand them so you can kind of see that this is joints if you wanted to. What means that you figured it out that if I right click on this one and I suppress that feature, and I right click and I unsuppress our other joints, then everything is flat. That's kind of interesting, right? Just an interesting scenario where we can actually use these. Right click, we can suppress one and unsuppress another, and then this is locked in and it's kind of the way we were. Or we could, suppress that and unsuppress the other, and we're actually down to a manufacturing model. It's kind of what we could do if we go back to suppress this feature, unsuppress that. Let me turn the handle back on. This is kind of the same thing that I would have done if I went into the manufacturer workspace and I had right-clicked, I added that manufacturing model, now I could have done all the things that I did. See, all the same commands are in here. I could have done all the things that I did in the version you just saw, and then it would have been flat in here in the manufacturing model, and in the design, it would look like this. Useful? I hope so. Okay. So, just kind of showing you a couple of different ways to do things. I hope this is not confusing. Go back and watch things again if you think it's too confusing. All right. One other thing that I like to do when we're doing the manufacturing here is it's nice to know what kind of stock we need. So I would actually probably create a sketch. So if we go back into our manufacturing workspace in here, and we have the handlers showing up in here, turn that off. Now I am in the manufacturing model here. Let me edit that. Actually, now I'm in the manufacturing model that you saw me using, and I have all the same tools in here. So let me hide the handle in here. So picture what we just did happening would have been down here. That would probably have been the right way to do it now. I would probably also go in and create a sketch on the top face here. Rotate it around. I don't know why I want to see it like this. This is how I'm going to machine it on this machine. And then now you could draw up some kind of a sketch to resemble our part here. I'm going to hit D for dimension. And this is where I'm getting confused between millimeters and inches. So I remember that this one here was 24 inches, like that. Apparently that's 610. And this one here, 22 inches. But apparently it goes to around that. And so this is going to be this is the stock that the plate I'm going to be using for this. And then you could either align it. I would probably just create a line up here or something like that to do that. Or maybe you're just deciding to put a dimension from here. This is not where I would be spending my most time. But I'll do something like this from this edge. Oops. From this edge to this edge. And maybe make it 45. Oops. This is the question. Do you want to place it right in the center of this? If I had been at Ridlam, then I would definitely go ahead here and create a circle up here. Doesn't matter what size. But I might just, so this one here I knew would be my pickup for when I programmed this, when I finish the sketch. And we could also choose at this point to extrude this. And I'm going to go minus to that face there, but I'm going to do this as a new body because this is going to be my stock. I'm going to use this as my stock when I'm simulating this. Hit OK to that. And then I could go in here and just, now I have that new body. There, and rename that stock. So then I know it's the stock and hide it. All right. Now let's finish the sketch. And we're back in our manufacturing model, and we're now in the CAM environment. And now we're ready to start setting things up here. So let's see if we turn the sketch on, we can see the sketch. So the first thing we're going to do is we're going to create a setup. When you do that, Fusion kind of had this tendency to look at, trying to figure out what we're trying to do. We're doing modeling. It's trying to figure out what are we manufacturing in here, the manufacturing model. In this case here, we are going to be doing all of these, right? I'm going to do all these. That's what we're going to machine. and our stock is going to be from a solid, and we can select that body that we had there, so we can see kind of like this piece of 12 millimeter plywood that we used. Okay. Now, I talked about this before, but I'll go through this again. When it comes to this work coordinate system, I go through the same way to do it from every single time. I always use like Z or Z and X. And then the Z-axis is someplace on my part here. And the X-axis, in this case here, is actually pointing in, it's in the wrong direction, but on the right line. So just probably, I don't have to select it. I can just flip it on this button. So you can flip it back and forth. And for the origin where it's going to be, I wouldn't select stock point. I would probably just select a selected point and then click on, that's going to be my pickup right there. And you will see that when you see the footage in a little bit, that's where it's going to, the 00 is going to be the G54. It's going to be right there. All right. So now we got a setup. So now I am ready to start throwing some toolpath on this one. And this is a very simple part to do and machine. So what I'm actually going to do is, I'm not going to face anything off because this is plywood. I am going to machine this, and I am going to use the 2D contour for this. So I'm going to select 2D contour. And when we go in and we're selecting, when we're going to start talking about, the first thing we're going to do is select a tool. Now, when you're selecting a tool, we got to talk a little bit about feet and speeds. I actually have a tool library in here. So I ended up using an Amana cutter, and Fusion actually have that library available. And I showed that in a recent video, but let me just show that again. So we have this library here. Let me just delete that for a second. Delete library. Choose, yes, delete it. Okay. And you will also see that I have my cloud. If you don't see cloud, you can choose in Fusion to either store your tools local, that's the default, or in cloud. The advantages of doing it on the cloud is that then if you go over to another computer, you will see, when you log into Fusion, the same tool libraries. This is great if you have multiple people to use that. And the way you turn that on is going up and click on your name, preferences, and then go into CAM, or manufacturer, sorry, and turn on enable cloud libraries. That is not by default, but if you do that, then you will see that cloud in the tool library, and that's where you will go ahead and find the library. Now, we're gonna come back to this in just in a second, talking about our feet and speed. So get to that library. The easiest thing to do is you can go out and you can search Autodesk tool library, and it should show up. And it's part of the cam.autodesk.com. You go out there, and here you will see I'm using the Amana tool library. There was one you just saw that I deleted. So what I can do is I can say for Fusion, and it will download that as a JSON. And let's go in my download folder. And now within Fusion, I can go over and click on my cloud library. And right up here, you will see you can import libraries. And I can now go out to my downloads folder, and there is that one. This is when I'm recording this right now. Double click on that, and that will bring the whole Amana tool library in here. And there is a lot of different tools. You can filter and things like that. So if I go in here and click on milling, filter up here on the milling in the new tool library that I like, we can go and say flat end mill, and then I want diameter, and I actually ended up doing a 6 millimeter, or it was actually a 1/4 inch because I live in the United States, and that was where I kind of ordered this as a 1/4 inch end mill. And you will see all the different amount of tools coming in here. Of course, the one I ordered, they didn't have in here, but it's fine. Let's see. So mine was actually coded. I don't know if that's going to show up. They don't have them as coded. Okay, they're all carbide. But I can probably find in here that will be somewhat close to what I need. So I am cutting. It's not a compression. So let's see here. This is a down router bit. So this is probably pretty close. I'm going to select this one. Now, if this was the one I had ordered, see it has the tool ID there. That would have been clever. Then I would actually have gotten, when I hit select here, I wouldn't actually have gotten all the feeds and speeds all set up in here. It would have been super helpful, right? And this is where we're going to start talking about some feeds and speeds. So, you know, we'll jump into that and deal with that right now. That would have been the easy thing. But of course, the cutter I ordered, I don't know why. I ordered one of these Spectra coded ones. Not like that. It's not in here. The one I ordered is this one here. So it is a it's a 1/4 inch, what is pretty much the same as 6mm. And we got to talk about a couple of things in here when we talk about feeds and speeds. And I hope this helps you a little bit when it comes to figuring out feeds and speeds. And they have a formula here. You can look a lot of this up on the internet. There's some great videos. My good friend John Saunders have done some great videos around feeds and speeds. So shout out to John. I really recommend that you use the cutter manufacturer's feeds and speeds as a starting point. That is the easiest thing to do. Now, I'm going to try not to make this too confusing, but there's two things you need to find when you are working with a cutter or a CNC machine. One is you need to find how fast you got to spin that spindle around, your RPMs. And second, you got to find the feed rate that you are going to be doing that with. Now, many times you will get offered up what is called surface feet per minute. In this sheet here, we don't, because Amada have actually taken care of this for us by telling us up here that they recommend using this router bit right out of the gate at RPM of 18,000 revolutions per minute. That's what that stands for. You can see that we could actually calculate what the surface feed is by saying 0.262 times the diameter of the tool times that 18,000 RPMs. That will give us the surface feed. But we don't need that. This is just a kind of a reverse calculation, because the two things we want is RPM, what we got here by this, and then we got to find the feed rate. So forget about the first surface feet per minute. Now, if you only got the surface feet per minute, many tool manufacturers, specifically in steel, will do that. Then the formula would be that surface feet per minute times 3.82 divided by the diameter of the tool. That will give you that RPM that in this case, again, is 18,000. That's locked in. And when you think about RPMs, you know, the faster you go with RPMs, the more, I guess, rubbing you could potentially see. But the second thing we need to find is the feed rate. So one thing we have now is how fast the thing is spinning around. Now we need to imagine how fast we are moving over the workpiece. And again, I always stick to the cutter manufacturer's feeds and speeds for a couple of reasons. You can always adjust it later on if you feel like it. But one of the reasons is that if you break cutters, many times if you go back to the cutter manufacturer, they will actually give you another end mill to help you out to use their tool and stuff like that. So that's why I always do that out of the gate. In this case, they are saying that our feed rate should be 180 inches per minute, or in this case, they give you a chip load per tooth of 5,000. Now, I'm going to just tell you quickly that that's in plywood, because that's what I'm cutting. You'll see here. Oops. Hang on, that bar go away. I'm doing this in plywood, not in laminate or MDF. So in this case here, it's 5,000 per chip. There it is. What in metric is 0.127 per tooth. So there's 2 teeth in this cutter. So this is kind of how thick the chip is going to be. And a tendency is to lower these many times when you're fiddling around with it. And that can be an okay, but if you're thinking about doing this in wood, if you make this number, the 5,000 here, or 0.127 millimeter, if you make that super small, what do you get? You're probably going to get sawdust. If you make it higher, then you're going to get splinters or, matches or, sticks, right? So like think about like the thickness of the tooth. Now, I like to use the cutter manufacturer's recommendation. So they are telling me that they recommend 18,000 RPMs, a depth of cut, because that's the third variable we have. How deep are we going to go with a cutter? 1 times the tool diameter, what in our case is a 1/4 inch deep, or 6 millimeters, at a chip load of 0.27 or 180 units per minute. Okay, so let me get back into Fusion. I hope this is not too confusing. So in Fusion, luckily we can see the 18,000 is already set, right? And then the chip per tooth I set was 0.127. That's if you're calculating 5,000ths of an inch. That's giving us a cutting feed rate of 4,572 millimeters per minute, what is pretty damn fast. Excuse my language. And I'll show you in the video. I'm going to show you in the video when I cut this out. I'll show you that actually feed rate, how fast that is. But that is pretty fast. Now, the third variable that we have not put in here is the depth of cut. And that is where I prefer to make my first adjustments, because there's a couple of things that determine the feeds and speeds. Now, at this point, we have done the RPMs, what is super important, and how fast we can cut over the part in a feed rate. That has a close variable on kind of the material we are cutting in. The third factor, the depth of cut, is more aligned with the size of our cutter and how rigid our machine is. How much power our machine has. And that's where I'm aware that on my Stepcraft, I for sure don't have as strong a machine as if I was doing it on a big router, if I was doing it on in steel or something like that. So my third variable is going out of the gate is to do the feeds and speeds by the cutter manufacturer. Then I will play with the depth of cut to figure out how much power my machine has. And I'm going to show you that again in real life in the machine. All right, enough of feed and speeds. Come back to that. I'm going to go ahead here and create my first geometry. And I like to start as far away from my 0, 0 as possible and then work towards it. I don't know necessarily if that's a good reason for that. Actually, I probably would drive the bottom of this part here. So I'm going to drive the bottom, go around there. That's good. Now I'm going to add some tabs to this. I'm going to check tabs. And by default, you get kind of like some tab widths and some tab heights. Now, this piece is 12 millimeter thick, and it only by default gives me 1.5, but it's probably good for if it was steel, but this is plywood, so 1.5 is not much to hold on to, so I'm definitely going to double that up to 3. And then I would probably play a little bit around with the width, right? So maybe I'll go up 12 millimeters. And you could also start playing around with the distance between them. Maybe I'll go 100 millimeters between here. And you can kind of see those tabs showing up. So I'm going to have a tap, 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 tap. That might be good. I'm going to stick with that. Maybe that is good. Maybe I say, you know what? If I go 75, I actually also get one on the end, but maybe makes me feel a little good too. Okay? Then we're going to go to the passes tab. And this is where I'm going to add some multiple depths, because right now it's just going to machine down to the depth. That's definitely not going to work. So I'm going to go and say multiple depths, and it defaults at the maximum step is 1 millimeters. Now, as you will see in the video, I decided to start out at a 3 millimeter depth of cut for this. But I actually did end up stalling the machine. So I did not have enough muscle in the machine. And in the finish, so I came back and I changed it. And in the finished, I ended up just doing 1 millimeter of depth. Now, if I turn the feed rate down, I might be able to have done this with more depth of cut. So right now I'm only cutting with, 1 millimeter of the depth of the cutter flute, what some people could say was wasteful. That is kind of pick and choose, whatever you want. Do you want to use more than mill, cut slower? You can do some time studies, whatever you want. The last tab I wanted to show is my entry. I like to choose where I'm entering the part. Now, if I just hit OK right now, you will see that it starts on that corner, and that's actually where I want it to. So I'm just going to leave that for this part here. This is my first toolpath. Like I said, when I originally programmed this, I did this with 3 millimeter step down, but again, on my machine, I ended up doing it with 1 millimeter. So I'm just going to leave that here. Now it's kind of rinse and repeat from this point. So what I'm going to do is I'm going to say right click and I'm going to say duplicate, because I don't feel like selecting everything again, right? We just changed all those different things. So I can go in here and say I'm going to duplicate this toolpath, and then I'm going to click on that. I'm going to right click, I'm going to hit edit, and on the geometry tab, I'm now going to select this part here and do that and hit OK. Now, somehow I like to have control over things. So we get the same toolpath, but I don't like where it enters the part up here. I actually want it to enter over here. So I'm going to right click and edit that toolpath. On the last tab, you can choose here an entry position. So if I go over here and I select here on this corner, hit OK, now you'll see that I just moved that over there. And I've always preferred to enter at a corner area instead of the middle, because many times you get a cutter suction in there. So this is pretty good. I'm going to go ahead here and right click and duplicate that. Right click, edit. And I like to break it down like this into different toolpaths, because if you machine the first two and then you could select all of them in one big swoop, but I like to break them down into different toolpaths like this. It just seems like it makes more sense when I come to the point where, let's say I machine 2 of them out and then I wanted to restart the program. It's easier to go in here and post things out here than on my controller to try to find out how to start in a certain place. Hit OK. I would like to start there. Go in and change that location to there. This is just my preference. And before I machine the outside of these two, I actually want to do the holes first before I machine around these parts. So what I'm going to do here is that I'm going to use the adaptive clearing for that. So I'm going to click adaptive clearing, but these two, I'm going to use the same cutter, same feeds and speeds. I'm going to go into this one, and I'm going to select this hole and select this hole. And if I go over This was actually, so I have here stock to leave. I'm not going to leave anything on the bottom. I would probably leave 1 millimeter on the walls because this is going to be my roughing operation. And you will see here that we have a step down. So we have an optimal load of 2.5 millimeter. So that's kind of like the step over. The maximum roughing step down, I had set it originally to 1, but either I should leave this at 1, and then I could probably bring my optimal load up quite a bit. I actually think I ended up leaving this at, after I did it, I realized that I could probably go 3 millimeters down on the on this, because now you're not engaging the tool full width like you were doing when you're going around these parts. Instead, you're kind of doing this cool adaptive. I'm going to hit OK to that, and that is going to rough those out. 1, 2, 3. Let it just calculate that. Actually, we don't have to wait for that because they could calculate while we're working. So for the next one, I ended up selecting a bore operation. Same feeds and speeds, same tool, and select these 2 faces here, and then go over here. And I think I just left everything a pitch of 1 millimeter. This is my finishing tool path, and that we'll see that run in the video. And that machine there, see, that is still calculating that roughing tool path. We can add more tool path by that, it's still calculating. And then to machine these out, I will just go in and do right click, and again do another duplicate. And you can drag operations in here too, just like you can do like on your timeline. So we can move this last one down, edit, and go ahead here and select this one. And let's just control it. I don't know why I selected my point in the video right now. I can't remember. Do that one. I don't know why this, I think maybe I did something wrong with this adapter maybe. And right click, do another duplicate, right click, edit, and for that geometry, let's start over here and do entry point there. There we go. I don't know why the adaptive is, oh, see, I selected something wrong here. Edit. What did I select? Oh, that's why. I selected wrong. I selected stock contours. What I needed to do was selecting in machining boundary. I should have selected here. See? Error between the computer and the keyboard and the chair. I couldn't understand why it took so long to calculate. Look how fast it's going now. Huh. See? I told you it was not perfect. All right. And now you will see here, this is an interesting one to highlight too. You will see here that we're getting a error here. And I'm going to wrap this video up because now this one is getting long too. If I right click and you go in and you say view log, it just says that warning toolpath generation was aborted by user. It just gave me that it realized that I stopped this in the process. These warnings don't mean that things are broken. It can just be an indication that you've done something. So somebody emailed me about this the other day. Just because you see a warning, right click and say show log and see why did it give me this. Toolpath generation was aborted by user. Okay, whatever. Right, because I noticed that something was wrong. Now we could go in and we can simulate this whole thing, right? We can play through it. So here we see the first portion of this part here, and of course we're looking for any collisions down here in the bottom in here. We're looking to see if anything is broken. We'll see we got our tabs in here. We maybe want to monitor how these tabs are on the two, because here it's going to be held together. And you will see that the way I did it, most of the tabs actually looks like they're going to be connected. So that's a good thing. Oh, see here how it does. It jumps between those two. That is not ideal. Let me just simulate this by itself. See here on the adaptive how it does here, and then it goes over and it does that. And then it goes back over and it does that again. That's kind of silly. Right click, edit, go into the passes tab. And I bet you that if we are looking for order by depth, no, order by area, then I bet you that it's going to do one, and then it's going to go over to the other area and do the other one. I know we're coming up on an hour here. I'm going to wrap this up. So now, if we go ahead and we simulate. Sorry, I couldn't find the simulate button. You will see that that now it's finishing one, and then it does another. Now, I'm going to wrap this up with a little trick here that I like to show. And that is that we just programmed all this, and this is all good, and I'm happy with this. But when I go out to my machine, I like to dry run the whole part first before I actually start cutting something, just because I'm not that confident in this. I don't use this router that often, and you know things can go wrong. Here's a little tip that I like to do. If you right click on your setup here, and we duplicate the entire setup. So now I got everything at twice, and I can just do here, and I call this dry run. What I will actually do is I will go ahead and I will edit these operations, and I can actually, I don't know if I select all these contour operations here, and then I right click, I can do a compare and edit between them. And this list is pretty long, but if I search in here, depth, I don't know if it's going to show it. Where would will that show up in here? Along the wall, so in the passes tab. See how we have a roughing maximum step down here on the passes tab. I actually wish that I could go in and turn them all off. But what I could do here was I could go in and change them all to 13 or more than 12, more than our thickness. I don't know if I do it at 12 and hit OK. And now I'm changing all those depths of cut to 12. Now you will see that I just changed all those toolpath, the contour toolpath, to only have one step. I could also have gone into each one of them, and I could have turned multiple depths off, because that's actually pretty much what I did here. But this was a quicker way to do it. And then I would probably suppress adaptive. I don't really need to see that in a dry run, so right click here and suppress that. Now what I will do is, and I was showing this in the video, I would post this out by itself as a dry run program. Then I will touch off my part. I would lift my cutter up 12 millimeters above the stock, and I will run this program just to make sure that I'm within the boundaries and everything is working the way it should. And then I would post this as my actually program. So let's go ahead and let's go ahead and post both of them out. So what I will do is I would right click here and go ahead and hit the post processing button. And you here see I have my Stepcraft post here. A common thing I just want to point out quickly that you might miss. First of all, notice that there's some options you can actually change certain things in here. So for example, my Stepcraft has a tool changer on it, so you can go and you can do different things. Well, it has a tool changer, but actually we've seen the video, I don't have it. But there's different things you can turn on and off in here. So like you can turn on something like sequence numbers, for example, if you want those on or not. So just be aware of that. Program number. This is just one of my small things. Like, I think every CAM program I ever used always have this 101 as the first program. I always changed that and gave it my own type of number. So I would normally do a order program. So I would call mine 7500, and I came up with this just if I always use 7500 and Bob or Fred or Paul or Lisa or somebody else use another number, there's never a confusion when you go over to a specific machine. You can always see who wrote the different programs. Now you can add that actually into your post. I used to have that in my Mastercam post. It would say who the programmer was, but that's a whole other thing. So I would normally name my dry run program 7500, and then my first program would then be 7501, 7502 as I'm going through, almost like a revision of each different program. So I'm going to go ahead and hit post, and it's going to tell you wherever you want to save it to. So let me just save this program out here, and it's going to open that up. Hang on. 7501, there it is. It's going to open up a notepad here on the right screen. You can kind of see the code. Now, I started this video by showing how I didn't know something about decal. I have not gone around to modify my post here either. This should be another video I should do. My Stepcraft don't like this line, so I'm going to delete that out. And since I'm doing this on a personal license, I don't want it to do a tool change either. I already have the end mill in the spindle, and if I call it T1 M6, then it's going to go over and take tool number 1, but it's already in the spindle. I'm going to delete that out. And another thing that I probably also should change is I actually want this C value here. I'm going to do a Control X to copy. I actually want that here. So this is me showing my dirty laundry. I should go ahead and get that edited out of my post. And I also, the last G53, I should delete out of here too. I would, if this was a production environment, like if I was a real professional, I would make sure that I never have to go in and edit things in this code, because it is just dangerous if you make a mistake. Hit file, save, and that would be my dry run program. And then I will rinse and repeat to do that with the actual program up here, setup 1. You could rename that. Instead of setup 1, you could call that, the program or whatever, if you have setup 1, setup 2, whatever. All right, with that, this was long. So first step is to go over and find the corner, and I'm sorry, my cutter here is going out of focus a little bit, but I'll go over here and just eyeball the corner of our plywood and go down and touch, and then zero out the G54, G55, and then you will see here that I raised the cutter up that 12 millimeters above the stock. All right, and here I'm actually running single line. So I'm just hitting the button for each single line. And this is just to make sure, like a little scary, that clamp right there on the lower left there. So I'm just kind of like keeping an eye on that. Again, running this a little faster than in real life here, but just keeping an eye on kind of that clamp there. Yep, I'm going around it. It looks pretty good. And here you will see this here is going to be, this is the right feed rate. So then I just said, okay, go. So this is the feed rate in real life that you will see how fast it's going to be cutting this. That I originally had set down to go 3 millimeters deep, but I'm actually showing here just in a second. You will see, so this plywood is not flat, and I knew there was a bow in it, but I really didn't know how much. But here the cutter actually stalls. So right here the cutter stalls, and you will see that I'll lift up the cutter. I zero back the machine, and then you will see I'm going in here, and I looked with my depth caliber and saw, all right, 3 millimeters was actually the depth. So I knew I couldn't do 3 millimeters. So that's the bow of this plate, and I actually end up in a little bit screwing that plate down also to my sub table. But again, I'm running this dry run program here just right over the cutter. Again, just to make sure that I don't have any surprises, and it sucks when you're getting halfway through and then there's issues. So this is just a good way. Now I'm speeding it up here, of course, to get through this whole kind of part, making sure that things aligns and everything is doing as you expect before you actually cutting everything. It's a little like you feel like this is a little bit wasted time, but of course if something goes wrong, it's always nice to kind of have that figured out. And here you see the bore cutting. So remember, I suppressed the adaptive, and here you see that and that was the plan all the time. I'm just going to screw it down to the sub and then go ahead here and cut. So here you kind of like just get a little bit of view. You can see these tabs being created, so the cutter goes up and down, up and down. Here's another picture. One of the things, so I took the tool changer off this machine, been goofing around, thinking about some different ways. Here I'm vacuuming up all the chips. So just like in steel, you don't really want the cutter to cut material again and again and again. So here I'm aiming with the shop vac, and I actually get sick and tired of this in a second, and I actually put my suction on it. But then you can't see the cutting one. Is a little boring. Here's the adaptive, roughing out these holes. And here you can see that I was done standing holding the shop vac, and I put the little attachment on it so I can actually, suck some of this dust up here. Just giving you a little bit of view of that from a couple of different angles. You can see the tools are sitting in the background for the tool changer. But again, I don't have it mounted on the Stepcraft right now, but it comes with a tool changer you can add on there. So here you are, machined it all through, and kind of take that piece of drywall out, and you can see all those different pieces are held in by the tab. And here I went in with a little saw. I can cut those tabs off, but of course, like most people, you're like at one point like, okay, screw it. You go on the bandsaw, and I kind of cut the pieces up over there instead. It was a little bit faster. And then really all I had to do was to go over on the sander here and sand them out. So that was the second way to do the Jimmy's Diresta toolbox with the CNC. I hope that you enjoyed this little project. It was fun to do. Really want to thank Jimmy Diresta for always inspire and teaching all his tips and tricks. Find it absolutely awesome. So with that, until the next time, I hope you have an awesome day. Take care, folks.